everyone, welcome to your second video. In our second video, what we're going to be doing is looking at the order of operations. Yeah, you might be saying, I've done order of operations before. That's okay. It's always important to go back and look at those skills so that way we can do them, because we're going to actually use order of operations in any math that we solve in algebra, 8th grade math, 7th grade math, anything above algebra, and anything below algebra. So order of operations is one of our most important skills. So our objectives for today is where we're going to be looking at how to evaluate numerical and algebraic expressions by using the order of operations. So we need to know what the order of operations are in order to solve our problems. Our standards that we're going to be addressing are the same standards that we had in lesson 1. We're going to be doing the algebra standard SSE.1b and algebra standard SSE.2. So let's go ahead and get started on our lesson. So, welcome to our vocab. For our vocab, we have two words, evaluate and order of operations. All the word evaluate means is that we're just going to solve a problem. So we're figuring out the answer, that's evaluating. Order of operations, most of you know Pemdas. And the problem is, a lot of people don't know what order of operations actually means. What the order of operations is it's a way of going and solving a problem so that everybody in the world gets the same answer. So the idea is we all approach a problem the same way, we solve it the same way, and we get the same answer. Now, in order to do that, most of you probably knew this phrase, please excuse my dear Aunt Sally. That's a good phrase to remember Pemdas. What Pemdas stands for is parentheses. You solve anything and everything inside parentheses first. Number 2, solve exponents. So after you solve everything inside the parentheses, get rid of any exponents. Multiplication or division. Now notice I use this word here. This is the word that a lot of people miss. Most people think that you have to do multiplication and then do division. That's actually not right. What you really have to do is you have to solve anything that has multiplication or division based on which one came first, going from the left side to the right side. So if you have division happening over here on the left, you have to actually solve that first before you do any multiplication. And the last thing that we have is addition or subtraction. Now again, they're using the word or, which means that we're going to have to use the same rule. It matters which one comes first, going from the left to the right, for you to solve. So if subtraction came before addition all the way on the left side, you actually have to solve the subtraction part before you do addition. So order of operations is an order, it's a set way that we have to solve problems. So yes, Pemdas works, but the thing that we're missing is it's multiplication or division, addition or subtraction. And we kind of group these together, multiplication or division, addition or subtraction. So you can use Pemdas, but you need to remember it's which one came first, going from the left side to the right side, that you have to do first. And if you do this, everybody should get the same answer. Let's go ahead and look at our first example. For example 1, our job says that we have to evaluate, which again means to solve. We're going to solve 2 to the 6th power. Now you read that as the number 2 to the power of 6. Now notice that the 6 is a lot smaller than the 2. That's because it's an exponent. Also, exponents only go to the top right. You never put an exponent in front of a number. It always has to be at top, and it has to be smaller than the base. Now, if you remember from the very first lesson, a base, which is this number here, is the number being multiplied. Where the 6, which is the exponent, or the power, tells us how many times that number is being multiplied. 2 is being multiplied by itself 6 times. So what we need to do is we need to solve this. That's what evaluate tells us. Now we're going to solve it using Pemdas. There's no parentheses, so we don't have to worry about that. There is an exponent, which means we have to eliminate the exponent. We're going to see if there's any multiplication, division, addition, or subtraction after we do the first part of getting rid of the exponent. So 2, there's an exponent, we have to get rid of that. So what we're going to do is we're going to take that 2 and we're going to expand it out. This is called expanded form. I have 6 number 2's here, and that's because this 6 tells me that 2 is multiplied by itself 6 times. So I see that 2 is being multiplied 6 times. Now, to evaluate, we actually have to solve. So I'm going to go through this a little bit at a time without a calculator. 2 times 2, that's 4. 4 times 2, that's 8. 8 times 2, that's 16. 16 times 2, that's 32. And 32 times 2 is 64. So this right here is actually equal to 64. So I'm going to go ahead and rewrite this. 2 to the 6th power equals 64. And that's my final answer. We evaluated the problem because we are actually able to find the solution. So in this one, we did have to do multiplication. We did not have any division, so we started with our multiplication going from the left side to the right side to get our solution. We did get rid of the exponent. We took the exponent away and made it expanded form. Then we solved based on the rules of Pemdas. If everybody does this the same way, we'll all get the same answer. Let's go ahead and go to our next problem. So for our second problem, we have evaluate 4 to the 4th power. Reminder that the base is the number that's being multiplied, and the 4 tells us how many times. So we're going through Pemdas. There's no parentheses. There are exponents, so we're going to eliminate the exponents. So we're going to expand this out so there's no exponents. So 4 times 4 times 4 times 4. Okay, so I have 4 times 4 times 4 times 4. If you don't know that answer, it's okay to use a calculator at this point. I'm not going to use a calculator though because I'm actually okay with figuring this out. So I'm going to show you how I would figure this out if I didn't have a calculator. So I would actually solve this because we have no exponents now. We have multiplication, so I'm going to multiply. 4 times 4, that's 16. 16 times 4, that's 64. I knew that one. And 64 times 4, I really don't know that, so I'm actually going to do it long multiplication ways by stacking it. So I have 64, and I'm going to multiply that by 4. 4 times 4, that's 16. I'm going to drop the 6, carry the 1. 4 times 6, it's 24. I add the 1, that's 25. So it's really 256 is equal to 4 to the 4th power. And there we have solved our problem by doing the order of operations. We eliminated exponents, then we did multiplication. On to example 3. Go ahead and pause the video, copy down this problem. All I did was write a new sentence. I changed the example number. Pemdas is still here because I still want us to refer to the order of operations when solving this problem. And now we're looking at 48 divided by 2 to the 3rd power multiplied by 3 plus 5. And our idea is, if we're not using a calculator, we maybe could solve this, and every single one of us can get the exact same answer if we follow this rule of Pemdas. So, looking at this, there's nothing inside parentheses, so we don't have to solve parentheses. There is an exponent, though, so we're going to have to get rid of that exponent right away. So, you are not supposed to do the division yet, because you have to get rid of exponents. So 2 to the 3rd power, I have to figure that out before I do anything else. So we have 48 divided by 2 to the 3rd power. I'm going to write 2 to the 3rd power, and I'm going to expand that out so I can figure out what that is. That's 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. So right now, I know that this is actually 48 divided by 8. So what we should do is we're actually going to rewrite that problem. We have 48 divided by 8 times 3 plus 5. So we rewrote the problem, so now we don't have any more exponents. Reminder, 2 to the 3rd power is what we actually figured out right here. Because Pemdas says we have to get rid of exponents before we multiply or before we divide. And remember, when we multiply or divide, it matters which one came first, going from the left to the right. So looking at this, I'm not going to take 8 times 3 because multiplication did not come first between these two. Division actually comes first. So it's important that we take 48 divided by 8. Well, that's 6. So I'm going to change this to 6. 6 times 3 plus 5. So if you look, every time that I do one of these steps, I rewrite the problem. And the reason why I do that is so that way I don't mess up my Pemdas. 6 times 3, because now there's no more division on the left side. There's no more multiplication, no parentheses, no exponents. So now I can do the multiplication. 6 times 3, that's 18. So I'm going to change this to 18 plus 5. And now, this is all my problem is. It went from 48 divided by 2 to the 3rd power times 3 plus 5 to 18 plus 5. If we all follow the same method, we'll get to the same answer. 18 plus 5, that's 23. So this entire thing that looks complicated can all be solved the same way as long as we all follow the same procedure, order of operations. We get rid of any parentheses, any exponents, multiplication or division. That's why I threw the little tiny word or in here, so that way we know we have to do which one came first. Addition or subtraction, and that's going to work the same way that multiplication does. Whichever one comes first, going from the left side to the right side. If we do the order of operations correctly, we all end up with the same answer of 23. If we don't, we need to go back and check what did we do wrong. So, example 4. This one looks even more frustrating than the last one, but that's okay. We have our order of operation rules, and we're just going to follow those. Now, one of the things I forgot to mention whenever we talked about order of operations is when looking at a problem, we see parentheses and we see brackets. So what actually happens is you start from the one that has the most inside and you work your way to the outside. And every time you start inside a set of parentheses, you still have to follow the rules of Pemdas so that everybody gets the same answer. So I'm looking inside this first set of parentheses, and I'm going to treat these brackets like they're another set of parentheses. So in reality, I'm kind of working like two sets of parentheses. So starting on the first inside, we're going to look, are there any more parentheses inside here? No. So we skip the P. We go right to E. Now, exponents. Well, there's an exponent here. 9 to the second power means 9 times 9. I'm going to go ahead and change that. So what I'm going to do is I'm going to rewrite this problem and only change this. 9 squared is equal to 81 minus 9 divided by 12. So all we did was change 9 squared to 81, because 9 times 9, because that's what 9 squared looks like, is 81. Now, we go back to Pemdas. There's no more exponents to solve. I don't see any exponents I need to get rid of. There is multiplication or division, and based on the rules of Pemdas, we first have to get rid of parentheses before we multiply or divide. So we need to get rid of this set of parentheses if we can. 81 minus 9, that's 72. So now, we really have 72 divided by 12, and I can take away my parentheses because we solved 81 minus 9, so I'm going to take away the parentheses. 72 divided by 12, and that's still inside brackets, which is like another set of parentheses. And then we have the 5 on the outside. We'll talk about what that 5 means here on the outside here in a second. So, we don't have parentheses now. We now have brackets. Brackets are just like parentheses. So again, we worked our way to the outside. Now we have to solve 72 divided by 12. That's 6. So we have 6 is inside of brackets. And I'm just going to solve it as putting it inside the brackets. And we still have that 5 there. So now it's important that we figure out, what does a bracket next to a number mean? Well, a bracket next to a number is just like a parenthesis next to a number. Anytime a number is right next to parentheses, that means multiplication. So 6 times 5, that equals 30. So if everybody follows the same order of operations of Pemdas, starting with the innermost parentheses and working their way to the outside, we all get the same answer of 30 by slowly working through a problem. Notice that each time that we did it, we changed our number, and then we went back and started the problem again. If you do this, it's hard to mess up because you're actually slowly getting rid of things by following these order of operations. So do your best to follow the order of operations and see if you can all get the same answer. Well, let's go ahead and do another one. Alright, so for example 5, we're still solving numerical expressions. A numerical expression is just an expression that just involves numbers. Notice there's no algebra here, no variables. And that's what we've been solving previously, and I forgot to mention that. Numerical expressions are a problem that has no variables, where an algebraic expression has at least one variable. So in this case, we're going to solve this by using Pemdas. We're going to start with anything inside parentheses and solve that first. So I have this inside parentheses and this. I'm going to go ahead and solve both of them because both of them are inside parentheses. 8 minus 3, that's 5. I'm going to keep this times 3. 3 plus 2, that's 5. So really, this problem ends up being 5 times 3 because we have to start from the left and work to the right. 5 times 3, that's 15. 15, and we talked about it in the last question, a number next to a parenthesis means multiplication. So 15 times 5, that's 75. So this answer is equal to 75 as long as everybody follows the same procedure. Pemdas. We solve parentheses, this one and that one, both equal 5. We had no exponents, so we didn't have to worry about that. We did have multiplication, so we solved their multiplication going from left to right. 5 times 3, 15. 15 times 5, 75. After that, there was no division, addition, or subtraction, so we didn't have to worry about that part of Pemdas. Again, if we all do the same problem, we all get the same answer. So, our next example. Even more challenging than all the other ones, but again, we're still okay because we have our rule. Pemdas. Parentheses, exponents, multiplication or division, addition or subtraction. So in this problem, it says that we're going to evaluate, again, which means to solve. We're going to solve 4 times everything that's in this bracket to the second power. So we have 12 divided by, in parentheses, 6 minus 2. This whole bracket goes to the second power. So what we're going to do is we're going to start in the innermost parentheses and work our way to the outside. We're going to go ahead and get rid of this parentheses. 6 minus 2, that's 4. So inside this bracket, and I like to just leave it inside parentheses, but since we've actually done 6 minus 2, we can take it out of parentheses. So we really have inside the bracket 12 divided by 4, but we need to remember that it's going to the second power, and we still have this 4 on the outside. Okay? Well, 12 divided by 4, that's 3, because again, we have to solve inside the brackets because we're treating them like parentheses. We got rid of the inner one. We work our way to the outer one. We're solving this one now, and then we're going to simplify that down. 12 divided by 4, that's 3. And I'm going to still keep this in brackets because I have this 4 randomly right next to it, and to the second power. Now, in order for us all to get the same answer, we need to say, are there any more parentheses, or anything we can solve inside the parentheses? In this case, there's nothing inside this bracket that we can solve since it's just number 3. Do we have an exponent? Yeah, since we have an exponent, we have to look to the right. This is actually a 3 to the second power, which really means 3 times 3. Well, that's 9. So I'm going to go ahead and change this right here to the number 9. Which really means that we have 4 times this answer, because that's next to the bracket. 4 times 9, that equals 36. So in this problem, our answer is actually 36 based on the order of operations. Alright, let's go ahead and do another problem. But now we're going to... Example 7. Talking about a fraction here, so we need to be able to solve this one. This one probably looks the most challenging, but we're still going to be able to approach it the same way. All a fraction really is instead of having one set of parentheses, we can actually make it like it's 2 sets of parentheses. So what I recommend is anytime you have a fraction, you put the entire top in a set of parentheses, and you put the entire bottom in a set of parentheses, and then you're going to use this line to divide them. Because what a parenthesis tells us is we have to solve everything up top, solve everything down below, because they're both inside parentheses, and then we're going to do this line that means division. So we're going to take the top answer divided by the bottom answer, but we first have to solve top, then we have to solve bottom before we actually do that. So, 2 to the 5th power. Well, that's 2 times 2, which is 4. 4 times 2, I'm going to write this out. 2 times 2, that's 4. Times 2, that's 8. Times 2, that's 16. And 16 times 2, that equals 32. So this 2 to the 5th power is going to change to 32. Now notice I'm not using a calculator. I'm just doing it all up here. This one says 3 to the 3rd power. So that means 3 times 3 times 3. 3 times 3 is 9. 9 times 3, that's 27. Now, I'm going to change these because I'm going to write this so that we know that 2 to the 5th power is equal to 32. And 3 to the 3rd power is equal to the 27. So I'm going to rewrite this problem with those changed, if you guys are okay with that. I'm going to change colors here. So we have 32 is going to replace the 2 to the 5th power, 32 minus 6 times 2, that's what's on top, divided by 3 to the third power, I'm going to change that to 27 minus 5 times 3 minus 2. And I'm going to still keep that inside parentheses. So now we're going to use the order of operations to solve this part. But before we do this, we have to look. Is there anything inside the parentheses that has exponents, multiplication or division, addition or subtraction that we can solve first? And based on the rules, we look at the top, and there's something that we need to solve before we subtract. We actually have to solve 6 times 2. Well, 6 times 2, and I'm going to be erasing this. If you don't have room, that's okay. Actually, I won't erase it. I'm just going to write it down here, so just follow along. 6 times 2, that's 12. So we have 32 minus 12 divided by, I'm going to keep this inside parentheses. Now on the bottom, we have 27 minus, now we have to multiply these first because multiplication comes before subtraction. So 5 times 3, that's 15. So 27 minus 15. And then that minus 2, I'm just going to drop it down. It's still there. I never did that yet. So now, here's where we're at. We have 32 minus 12 divided by 27 minus 15 minus 2. Well, 32 minus 12, that's pretty easy. 32 minus 12, that's 20. Divided by 27 minus 15, because we start left, we work our way to the right. 27 minus 15, that's 12. 12 minus 2, that's 10. So really, our answer is going to be 20 divided by 10. And 20 divided by 10 is the number 2. So 2 is our final answer if we all follow the same Pemdas rules. We had to get rid of our exponents. We treated it like the top was in the set of parentheses and the bottom was in the set of parentheses. So we solved the whole top, solved the whole bottom, and then we took our top, divided by bottom, after we were able to get rid of our entire parentheses. So we always get rid of parentheses, we get rid of exponents, we multiply before we do any addition or subtraction, and then we solve our problem. If everybody does the same way, we all get the same answer. Let's go ahead and do our next problem. I decided to change colors for our next example. We're going to go ahead and call this example 8, I believe. So we're going to evaluate. Now we're evaluating algebraic expressions. I think I said the last one's going to be algebraic expressions. I was wrong. This one's going to be algebraic expressions. And the reason why this is an algebraic expression is if we look here, there's no equal sign in the problem. And now we have algebra because we have variables. So this says evaluate 2 times the quantity x squared minus y plus z if x equals 4, y equals 3, and z equals 2. So now in this case, they're telling me what these variables are equal to, but we're looking at variables in the problem. So one of the first steps before we do Pemdas is we actually have to change our variables based on what they're equal to. This is called replacement or substitution. We're going to substitute these values in for those variables. And it substitutes when a number takes the place of a variable when they are equal to each other. So, I know that x is 4. So this x is going to change to a 4. And I know that y is 3. So this is 4 squared minus 3 plus z. Z is 2, so plus 2. And this 2 is here. So all I did was rewrite this problem that's algebraic and made it numeric by only using numbers based on the information we have here. Now we're just going to use Pemdas to solve the problem. So we need to get rid of 4 squared because exponents go away inside parentheses first. 4 to the second power means 4 times 4, that's 16. So I'm going to change 4 squared to 16. And now we have no exponents, so now we're going to solve inside the parentheses before we do any multiplication, division, addition, or subtraction. 16 minus 3, solving inside the parentheses, that's 13. We still have that 2 there, and we have plus 2 on the outside. So we just solved this set of parentheses to get 13. Now, there's nothing inside this set of parentheses that we can solve, so we're going to see, is there any multiplication or division? Well, 2 times 13, that's multiplication. 2 times 13 is 26. And then we're going to add that 2. So 26 plus 2 equals 28. So even though this is algebraic and it deals with variables, all we do is replace the variables with what they're equal to in the original problem. So we rewrite the problem. We solve by using our order of operations as we've done in, I think, 7 other problems today. And then we all should get the same answer. As long as we're doing the order of operations correctly, we all should. And if you aren't getting the same answer, please come see me. I'll help you out and figure out maybe what piece of the Pemdas we're doing wrong so we can help each other get the right answer. For our 9th example, which is a lot of examples, and I congratulate you guys for getting this far, for our 9th example, we're going to evaluate another algebraic expression. Again, it's algebraic because it deals with variables, and it's an expression because there's no equal sign. X to the 3rd power minus y squared plus z. If we know that x is going to equal 3, y equals 2, and z equals 5. So we're going to approach this kind of like we did the other one. First thing before you solve this is you have to change all of these numbers right here based on the variables into the problem. So anywhere you see an x, change it to a 3. Anywhere you see a y, change it to a 2. So right now, this should actually look like 3 to the 3rd power minus 2 squared plus 5. And based on the order of Pemdas, we have to say, well, there's no parentheses, there are exponents. I did erase the Pemdas. I'm seeing if you're getting it now. So we're going to solve, because we have exponents, we're going to get rid of those first. 3 to the 3rd power. Well, we learned earlier that 3 to the 3rd power was 27 minus, well, 2 squared means 2 times 2. 2 times 2 is 4. And then we have plus 5. So now looking at this problem, we've gotten rid of all the exponents. These exponents are no longer there. We've changed our exponents to the actual answer. Now, Pemdas says we do addition or subtraction. It matters which one comes first going from left to right, so that way everybody gets the same answer. So we're going to take 27 minus 4 because subtraction came before that addition. 27 minus 4, that's 23. And now we can add the 5. 23 plus 5 equals 28. And as long as everybody approaches this problem the same way, everybody will get 28. Now, if you would have took 4 plus 5, that's 9, and 27 minus 9 would give you a total different answer. This is why we have the order of operations. So we know that we do subtraction before addition if it came first, going from the left to the right. Alright, example number 10. We're moving on to real life problems. Just trying to get done with this lesson now. It says find the area of a triangle with a base of 123 feet and a height of 62 feet. So we have 2 pieces of information. Now, one of the things that I'm requiring you to do is remember, how do I find the area of a triangle? Well, if you remember from maybe 7th grade or 6th grade, the area of a triangle is when we take our base times our height and we divide it by 2. So I'm just going to write that. B times H divided by 2. In other words, it means we're taking half of our base times height, because a triangle is half of a length times width. So base times height, and we're dividing it in 2 because we're taking half of it. Well, in this case, they tell us the base is 123. So that means that I'm going to replace my base, which is the letter B, with the number 123. And then it says the height is 62. So again, we're replacing it with the number 62. So it's really 123 times 62 divided by 2. Now, I'm going to go ahead and use a calculator to solve this problem. Just because 123 times 62, I could do that, but a calculator helps so we get there a little bit quicker. 123 times 62, that equals right here 7,626. Then I have to take that answer and divide it by 2 because we had to solve the top before we divide by the bottom, as we figured out in previous examples. Always solve the top of your fraction before you divide it by the bottom. And make sure you have top and bottom solved first. 7,626 divided by 2 is equal to 3,813. Now this is feet, so we need to put a label on it. Squared. So what we just did is we took a real-life example that ended up finding the area of a triangle, and we made it algebraic by writing this first statement. Algebraic is where we're just using variables. Then we replace this algebraic expression with the information given to us here to find our solution at the end. That's it for today. You guys did awesome. See you tomorrow. Make sure you have the notes. Come up with any questions that you have. We have tons of examples to practice in class, so be ready to do that.